It's nice to see you all today. I hope you guys are, enthusiastic about the next three days to learn more about WSO2. So welcome to the IAM track. I hope you guys will find this track interesting and useful and remain throughout the day with the track. So my session is going to be slightly different from the following two sessions. So this is more of a architecture session. So here we are going to talk about some of the basics. So I'll cover some of the basic stuff so that we get ready for the upcoming two sessions. So I'll lay the foundation, and then I'll talk about some of the patterns that we commonly use, and then some of the use cases. So it will be void of any demos. All the demos are going to be coming on the next two sessions. So before going into the details, I thought I'll start from here. So IAM is a very broad area. Identity is a very broad area. And there are many technologies that fulfill identity in an organization. So this is a reference diagram by Gartner, which is called the identity fabric. So the idea of this diagram is to say that, IAM is not a single technology or is not a single vendor solution. Rather, it's a combination of different capabilities that are stitched together in order to fulfill enterprise IAM requirements. So in this diagram, what we fulfill is the AM part that you can see at the bottom, which stands for access management. Right? So most of the things that we are going to talk about today and demonstrate today is going to fall under that category. So this is kind of the official definition. The identity fabric is an evolution of the organization's IAM infrastructure that is architected to enable identity-first security. Right? So the keyword here is identity-first security. So what is identity-first security? So historically, identity, before even IAM, all the identities were siloed within the applications, right? Then we moved from siloed IAM into what we call like a centralized IAM, or having a centralized identity broker where all the identities were centralized. But now with more modern applications and different kind of applications, infrastructure applications, mobile applications, cloud applications, etc., we are seeing a shift again from centralized IAM. The IAM is moving more towards to live within the application, and there are some specialized programs that are running within the application. So what's happening is that the controls and the governance is still with the IAM, but the enforcement is happening at the different specialized applications, right? So it's kind of a more distributed system now, IAM. So that, but basically, identity-first security means that IAM is kind of the control center for all the applications. So all your governance policies and rules are all in one place. So identity-first security, again, the official definition, again from Gartner, identity-first security is an approach that makes identity-based controls the foundational element of an organization's cybersecurity architecture. Okay, so then moving on, we dive into access management. So under access management, so we have access management. So access management is a very foundational layer for any organization, right? So almost all organizations need access management. It's a common requirement. And within access management, we have different segments such as business to consumer, business to business, business to employees, and then access management for APIs, right? Then we have these specialized technologies. We have identity governance and administration, privileged access management, web access management. Now these are not always needed for all the organizations. These are more specialized requirements, right? So large organizations might need identity governance when there are multiple functions, multiple people dealing with identity, so on and so forth. When there is when it's a small organization, centralized IAM, maybe you don't need IGA. Privileged access management is also somewhat of that same thing. In certain cases, you may need privileged access management. And web access management is mostly when you have like legacy applications that cannot work using standard protocols, right? So these are like specialized needs, but access management is a common requirement for most organizations. And most organizations, when they start on their digital transformation journey, they usually start with access management. I'll not go into the details of these features in this slide, but we'll talk about them in upcoming slides. So access management is also very fundamental to providing a good user experience. So good customer experience or user experience comes from access management, right? So be it employees or be it customers or partners, access management is important. Okay, so before going deeper, I thought I should start with the background because there are, the audience here is from a wide variety of backgrounds. So I thought I'll start with giving a background before going into details. So if you start with like traditional applications, we've seen traditional applications have various methods of authentication. We've seen basic authentication, digest-based authentication, client certificate authentication, form-based authentication, etc. Right? So these approaches have their limitations, right? And when we come to modern applications, what are the differences we see? So we have, when compared to traditional applications, we had identity silos, and in modern application, we have centralized identity brokers. Traditional applications were more monolith applications, whereas modern applications are more service-oriented architecture. Traditional applications had more broader access control, and modern applications have more finer access control. And obviously, traditional applications have no concept of data sharing, but modern applications with the service-oriented architecture and etc., it has a requirement for data sharing. So the traditional security authentication mechanisms don't really work for the modern applications. So then we came into identity brokering. So this was like the, this is the very first pattern we are going to discuss. So identity brokering is about centralizing all your identities into a single IAM system, or we call it IDP. And whenever an application wants to authenticate users, it will talk to the IDP using one of these protocols. So we have SAML, OpenID Connect, and WS Federation. So we'll not go into the details of the protocols, but basically the application will talk to the IDP, get the user authenticated, and the IDP is going to return to the application the user details. It contains some unique user identifier, some attributes, some groups, and some role or entitlement information. So this is basically what happens in login using an identity broker. So basically, when all the applications connect to a single IAM system, basically your login is centralized. So therefore, now you can get like single sign-on. So since each application is depending on the identity broker, we automatically get single sign-on, right? The identity broker is able to identify that this user has already logged into one application, so now he can automatically log into the next application. So at a very high level, if we look at the OpenID Connect flow, so this is just for an example, so each flow has its differences, but OpenID Connect being the most popular standard for single sign-on today, at a very high level, what happens? The application, when the user is accessing the application, whenever the user needs to log into the application will redirect the user to the IAM system, right? The user gets redirected through the browser, typically, and user enters his credentials. This may be, username, password, or OTP, or whatever, or FIDO keys. They log into the system, and then the application is going to the identity server or identity broker is going to redirect the user back to the application, right? And in the OpenID Connect authorization code flow, when the identity server redirects, it redirects with a code, right? So what does this code represent? The code is basically saying that this particular user has authenticated, and this user has given these permissions to the application to access his profile, right? That's what the code represents, right? So this code goes back to the application through the redirect, and the next step is the application is going to call the identity server or identity broker with this code, and also it will send its credentials. So we call it the client ID and client secret, just like a username password. So the application is authenticating itself and sending the code and getting what we call an access token and an ID token, right? So with the code, the identity broker can identify, okay, the user has given the permissions already, and now the client is authenticating, the application is authenticating. So I will give back a valid ID token and an access token. The ID token is basically the user's identity, right? The identity information is there. Access token is basically a delegated token by the user to the application to call APIs, right? And the access token contains what are the permissions or scopes that the application can access, right? So this is the very high level flow. So then, okay, so we looked at, how user is accessing applications that all connect to a single identity broker. Then we have the requirement where you are going to access applications across domains, right? You're accessing applications within your partner domain, right? So that is what we typically call identity federation, right? So when you are accessing applications that are outside of your domain, we call that outbound federations. When external people are accessing your applications or coming into your identities, coming into your organization, that is what we call inbound federations. So the protocols are very similar. So whatever the protocols we used for login to your internal applications, it's the same when you do federations. The only difference is there is an identity broker who is going to communicate with the identity broker in the external organization or partner organization or whatever, right? So that is what we call federated identity. So with federated identity, basically, so if you take your organization, you may be accessing cloud services, right? So your the outbound federations, right? Then there may be partners who are accessing your applications, so inbound federations. Then there can be customers who are signing up through social login. Again, it's an inbound federation, right? So basically, you can see in an organization, there are multiple inbound and outbound federations. So that is what we call federated identity. So then we come to data access. So this is a very old slide I got from one of the ex-WSO employees, Prabhat. So this is a very famous slide we used to use. I don't think we can get these screenshots anymore. But basically, when we talk about data access, in those days, there was no standard protocol for data access. So data access was done by providing your credentials to the application. So if you are going to access data of application A from application B, you are going to give your credential of application A to application B. So there was an implicit trust relation. I mean, you had to trust your credentials, right? So this is what basically OAuth OAuth 2 protocol solved. So again, the protocol is very similar to what I explained earlier with OpenID Connect. I said at the very last step, you are getting an access token. So that is what carries the permission in order to access your data across different application domains, right? So OpenID Connect is actually a protocol built on top of OAuth 2. Right? So this is basically kind of the background I wanted to set. So the different login protocols, federation, and then OAuth at a very high level. Okay. So then we move to the IAM for consumers and employees. So what are the capabilities and patterns that we see with consumers and employees? So when we look at the critical capabilities for consumer and employee IAM, we can broadly categorize them into 4 categories: registration, authentication, authorization, and account management. So in this session, we'll mainly look at the first 3, registration, authentication, and authorization, which is more relevant to how the architectures are going to be designed. But these are all the capabilities under consumer and employee IAM. Right? So I'll not spend too much of time on this slide. So then, first of all, onboarding, right? So what are the patterns we can see in onboarding? So when it comes to consumer IAM, we see a lot of self-registration, right? So basically, when you want to access an online service, basically it's going to prompt you for a self-registration page, and then you fill in your details, and then create an account and access the service, right? So that's what we call self-registration. So in addition to self-registration, then some websites can ask for email verifications, right? So you self-sign up with an email, but you're not immediately activated. You need to do a OTP, a verification of your email address, and then you get access to the service, right? And as part of this, you get provision to the user store as well, right? So that's self-registration and email verification. Another form of onboarding is invitations. So self-registration we mostly see with consumers, but invitations we would mostly see with employees, right? So with invitations, what happens? Administrator is going to send an invite to your email, and you're going to click on that invite, and then you're going to verify by clicking. Basically, you're verifying your email address, and you're proving that you own the email address, and then you're going to set up your account in the system. So this is what we call invitation workflows. Then we have just-in-time provisioning workflows, right? So typically, when you sign up to any social media any service in the internet using social media, this is the technique that is used, just-in-time provisioning. That is basically you're saying I need to sign up with either Google or Facebook or some social identity, and then once you log in through that social identity, by verifying that social identity, again these also use the same technologies like OpenID Connect or auth. By verifying the ID token, they are going to create an account for you in the service that you are going to access. So this is what we call just-in-time provisioning. Now, so this is the illustration of that. So basically, if there is an application, if you are going to log into that application, so this application is brokering the authentication to IAM in the middle, and IAM can connect to any social identity. So in this case, this IAM is connected to two social identities, Facebook and LinkedIn, right? So the user first chooses, I want to log in with Facebook. So it will federate you. Again, it's a OIDC request. It's going to Facebook, and user is going to enter his credentials, come back, and the IAM is going to create an account for you, a just-in-time provisioned account, and give you access to the application. Now, say the next time the user say he has forgotten that he has signed up with Facebook and he clicks LinkedIn, right? But fortunately, the email address that he uses for LinkedIn and Facebook is the same. And then on the IAM, we can configure rules to say that if the email addresses are verified and if they are equal, link both the accounts, right? So then automatically when he comes from LinkedIn, we know that this is the same user, and we can automatically link him to the same account that was previously created, and he will be logged into the application with the same profile, right? So that is kind of an account linking. So when we talk about account linking, there are two types of account linking. One is implicit linking and explicit linking. So again, account linking means there are identities, accounts in two or more systems that refer to the same identity, the same real world user. So we can link those identities. So with implicit linking, basically the link is suggested through some rules which require further verification in order to be confirmed, right? So for example, when you say rules, you can say, okay, if the first name this many letters match, or the last name this many letters match, if the email matches, if the mobile phone number matches, whatever, you can write your rules, and still it cannot be confirmed, so you need to verify the user by asking some questions, and you can confirm the link, right? And of course, there is certain level of risk, so the administrator who configures has to accept the level of risk in order to do that. So that varies from use case to use case and industry to industry and business to business, right? When it comes to explicit linking, there is a clearly stated link saying this user is mapped to this user, right? So with implicit linking, so like I said, some examples, we can, if we say, okay, by matching the verified email addresses in the two sites, say the Facebook email and the email in the local user directory is the same, then you can link, right? So that's an example, right? And you also have to make sure that the claims or attributes that you use to link are verified, right? So that's an important security property that you have to make sure. So admin has to make sure that those are verified. Then we have interactive account linking. This is where we can, when we can infer that there is some relationship here we can ask more questions from the user and get him to enter the password, prove his ownership, maybe do a verification. If the email or mobile is not verified, we can just in time do a mobile verification and then ensure that this is the same user and then link. So that is interactive account linking. So under explicit linking, we have two examples. So one is when you do a just-in-time provisioning, like the social identity use case I said. So that is explicit link. So basically, there was no identity before. So you are just creating the identity. So obviously, it's automatically linked, right? And if the same email is coming from a different account, you can link as well. So that is explicit because the same identifiers are there. Then you can also link based on external knowledge. So these are also common cases where the admins can come and upload some sort of a mapping saying these users are mapped to these identities from an external organization. So this typically happens in B2B federations or partners. When partners need to access, a typical workflow is they give the set of identifiers for their users and they need to be mapped into the partner organization. So that kind of happens offline and it's based on external knowledge, right? The identity server cannot infer that. Okay, so this is an example I'll walk you through. So linking based on external knowledge. So this is just a use case that actually came to us and we did. So there is this self-care portal and the same organization or actually another kind of subsidiary organization has a billing portal, right? So two portals and they have their own identity providers, right? Now these users who log into the self-care portal using the self-care IDP, they log in with the email address, right? But on the billing portal side, the same user can have multiple billing accounts. Say these are like in the telco domain, right? So they have an email address account, and then in the billing portal for each mobile number they use, they have a billing account, right? So one account on the self-care portal can be mapped to multiple billing accounts, right? So how the flow will go is basically the user will first log into the self-care portal using the self-care IDP, using email address and password, let's say. And then on the self-care portal, he sees a kind of input to enter his number, right, and enter his mobile number. So then he will enter his mobile number and click, right. So this will redirect him to the billing portal, and the number he entered also will be passed to the billing portal, right. And then the billing portal now is, the billing portal's identity broker is the billing IDP. So since this user is a new user, he has not previously logged in, so it's going to redirect him to the billing IDP. And the billing IDP, what it's going to do is, because the billing IDP is set up to federate with the self-care IDP, the billing IDP in step number 6 is going to federate to the self-care IDP with this mobile number, right? And the self-care IDP, so this is where the external knowledge comes in. So there is this association table where there is knowledge saying this email address is linked, or this email address owns this mobile number, right? So that's like backend knowledge that has already been created. So then the self-care IDP is going to look at this knowledge base, and it's going to find, okay, this user is so by the way, when the user gets redirected to the self-care IDP already knows who the user is because he logged into the self-care portal, right? So it already knows the email address. So when the billing IDP redirects him to the self-care IDP, he already knows the user, the email address, and now this number is coming. So this email address is mapped to this number, which is there on the table. So it will send back a successful response to the billing IDP, and then the billing IDP will send back a successful response to the billing portal, and then user can view the billing information in the billing portal. So that's how basically it works, right? So in case, let's say, there was no account mapping in the self-care IDP, then what's going to happen? The self-care IDP is going to detect that there is no account here. Either it can show an error, or it can do an interactive account linking at that point, right, by sending a OTP or something and verifying that this same user owns the mobile number, and then return a successful response to the billing IDP. So that's an alternative course of action you can take. Then in case let's say the mobile number is no more there in the billing IDP, then again the billing IDP needs to make sure that such an account exists and it's valid, and then only it should return to the billing portal. Otherwise, it can fail the login at that point itself. Right? So these are some different scenarios we can do with account linking. So another way of onboarding, of course, is directly integrating your user repository to the IAM system. Right? So this is a form of bulk onboarding users, mostly used when you have an existing set of users and you are going to plug them into a new IAM system or something like that. Then we also have an API which is called the skim to bulk API, which also kind of does the same thing. So these are bulk onboarding mechanisms. And in case there are applications that don't conform to like standard protocols such as skim to bulk endpoint or any other protocol, then we need to set up some sort of a custom onboarding process, right? So say this target application can be any application. It can be an IAM system, or it can be any other application. And say it only can kind of consume like a CSV file or something like that. Then we need to set up that through a integration flow, right? And who better than WSO to set it up for you, right? Because we have the tools to do that. Another way of synchronizing, so we looked at how we can onboard into the IAM, right? Now this is about when an account or identity is onboarded to the IAM, the identity can turn around and onboard the same users to other applications, right? Because certain, mostly cloud applications, they need to have some sort of account that is provisioned in order for users to access. Although they can connect to an identity broker and do single sign-on, still they need to have an account that is provisioned on the cloud system in order for the users to access. So before they access, it needs to be provisioned, or just in time as they access for the very first time, accounts needs to be provisioned. So to do that, we can use what we call outbound provisioning from the identity system to various cloud systems. So this is another pattern to provision users to other applications. Okay, so these are the different techniques of provisioning, how the provisioning is getting, how the onboarding is getting triggered, right? So once the onboarding workflow is started, there are many components that can be used to compose that onboarding flow, right? So the main point I want to highlight through this slide is that more and more these identity workflows are really a journey time orchestration of the user. So if you take login, if you take registration, if you take password recovery, so traditionally most of these were like configurations in the admin console, but more and more these are composable flows, right? So most modern vendors are providing like low-code editors, drag and drop editors to support these kind of flows. So for example, if you want to configure this kind of a flow, it's really hard to do it through an admin UI, right? So basically what this says is a user starting a login flow. So this is an example of a login flow. He can end up in three different possible outcomes. He can either end up with a zero-factor authentication. If his device check and location check passes, he can end up with zero-factor. Or if he can end up with a passwordless authentication, if the location check is medium and the mobile push is successful, then he can end up with a passwordless authentication. Or he can finally end up with a two-factor authentication by providing password and mobile number, mobile push authentication, or he can, of course, fail the login. So there are multiple outcomes. So in order to configure this, you need a kind of a low-code orchestration editor. So this is what we call democratization of IAM, right? So configuring these flows in code requires a lot of programming expertise, right? So we don't want to do that. So the organizations don't have the kind of skills, and they don't have the budgets to hire these kind of specialists in the organization. So therefore, you need to democratize IAM and make it more easier for organizations to use these kind of tools. So that's why we provide these kind of features like low-code editors in the IAM broker. So with that, if we look at the different onboarding workflow components. These are, this is not a finite set. These are some of the popular ones that are there. So quickly taking you through some of these. So then there's CAPTCHA to mitigate like bot attacks. We have identity proofing. So when you're onboarding to a service as a consumer, you might want to verify your documents, or you might want to verify your biometrics. So you can do that with identity proofing. So you might want to verify your, so if you've already registered with this organization by going to their office or something like that physically, you might have already given your mobile number, and then you might, when you want to onboard to the online portal, you might want to do that OTP. So they might ask you to verify the OTP so that they can make sure that you're the same user who came and registered in the office, right? Similarly, when progressive profiling, so prompting to get more attributes, right? So during the onboarding process, initially when you sign the form, you would have given few attributes, but when you're onboarding to the online portal, you can be asked for more attributes. So that's what we call progressive profiling. And then we have consent. Of course, you need to be able to say, the service should say, what are we collecting the information for, right? And you can, there are some mandatory consents and there are some optional consents which you can untick if you want. Right? Then in certain employee-facing scenarios, there may be human approvals that are needed. Typically in consumer-facing scenarios, you won't need this unless it's a very special case, but employee-facing scenarios, you need that, right? And then as part of these workflows, of course, your account is going to get provisioned in a user store. So that is there, as well as it can get provisioned to other SaaS systems, as I told you before, outbound provisioning. Then certain systems may have a step to input a password. So for example, when you do a social sign-up, typically you don't need to give a password to this service because you're always going to log into the through the social sign-up, through the social website. But in some cases, even if you log in through the social website, some services require you to enter a password. That is because they accept the social login as a sufficient assurance level for registering into the system, but they don't accept the social login as a sufficient assurance level to log into the system, right? So that's why they want to create their own passwords. And then additionally, you can enroll two-factor authentication during the onboarding process. You can enroll biometric authentication. If there are other workflows, you may want to lock the user account until those workflows are completed, and once it's successfully completed, you can unlock the account. And then there can be, of course, custom workflows that you can build. So all these things can be composed using the low-code orchestration editor. So that's the idea, right? So there is no particular flow for these components to be composed. Identity proofing. So there are simple ways of doing identity proofing. So like I said, so this is, for example, you're giving your account number and a PIN that you already have with the organization. So this is an example from one of our customers, Seminole Hard Rock. So this is one way they activate the online account. So they already have an account number and a PIN with the properties, Seminole Hard Rock properties. So they can provide that on the online portal and prove their identity and then get access to the online account, right? So that is kind of a knowledge-based identity proofing. So then there are more advanced techniques like document verification and biometrics-based identity proofing. These are more advanced identity proofing capabilities, and we also have some vendors who we integrate with in order to do this kind of identity proofing, which I'm sure you may be able to see during the demos. So this is an example of prompting for additional attributes during the social sign-up. So for example, when you try to create an account on adobe.com, I can use social login, but then still I need to provide additional information such as the country, date of birth, etc., in order to create the account on Adobe. As I said before, like certain applications force you to enter a password even if you have done social login, right? And then onboarding, enrolling a biometric authentication as part of the onboarding flows. For typically, if you have enrolled to bank applications, you would know after typically you would enroll using, one of the examples is enrolling using your credit card. You can enter your credit card number and the credit card CVV or PIN, and then you basically verify yourself, and then you go through the enrollment process, and at the final step, you do a biometric enrollment for easier login the next time, right? So these are the typical components. So that's about onboarding. Right? So then we move to authentication. Okay. So user authentication, again, is a journey time process similar to onboarding that provides credence in an identity claim, right? By a person already known to an organization. So when we talked about onboarding, onboarding is a person who is unknown to the organization, right? But authentication is about verifying a person that is known to the organization, right? So that's the difference. Yeah. So there are many authentication methods that are available. I think you might be familiar with these basic concepts. There are knowledge-based authentication factors, token-based or possession-based, biometric or inherence-based authentication factors. And then you can combine one or two or more of these authentication factors, which we call multi-factor authentication. But the idea is that when you do multi-factor authentication, typically the organization wants to, for the assurance level, to be within its risk appetite, right? So it doesn't matter how many factors you use, it should be within the risk appetite. In certain cases, they might be willing to go up to a risk tolerance level, depending on what kind of information they get back from the users. So it should be ideally within that risk tolerance and risk appetite levels. And there is this misconception saying, the more factors you use, the more strong it is, which is not true. There are certain methods which can be by itself are more stronger than combining two factors, right? So always more factors doesn't mean more strength of authentication. So just wanted to touch on FIDO very specifically because it's becoming more and more popular and it's widely being adopted in the mass market. So FIDO, now most of you would know this as passkeys, but the technology, the standard behind that is called FIDO, right? So FIDO gives very good user experience and very good security. So that's why it's becoming very, very popular. It's very simple to use. You just use a single gesture. You sometimes need to touch the FIDO device. So if you use FIDO devices, typically it's like a USB key. You can put it in and touch it, or it's sometimes integrated with your laptops, or sometimes it's there on the mobile phones as well. So it's like a single gesture. You sometimes need to touch it, or sometimes it reads your biometrics. And it's possession based because there is a key or a device that is involved. And also, most importantly, it's phishing resistant, right? So that's the most important property about FIDO compared to other possession based authentication factors, which is phishing resistance. So how does FIDO work? So basically, the user has a FIDO key, right? And whenever he wants to access a service, he's going to present his FIDO key. And the FIDO key, or the authenticator, we call it, it's going to negotiate with the server, and they are going to establish a public key, private key pair. So for each service the user is accessing, the FIDO key or the authenticator is going to establish a unique public key, private key pair. Though the private key is going to be specific to the user and specific to the service. So that's how FIDO works. And the private key is going to be stored in the authenticator, public key is going to be on the server. And in order to unlock the private key, the next time the user wants to access this service, they need to unlock the private key, then they need to do a biometric or some form of local authentication with the FIDO device, and that's going to unlock the private key, and then it can communicate with the server. That's how typically it works. Now, how is it going to prevent man in the middle? So take, for example, there is a website, legitimate website called bank.com, and user is trying to access that. Now, say there is a man in the middle attack. There is an attacker called and he's exposing a domain called maninthemiddle.com, mitm.com, right? Now, for the naked eye of the user, this website completely looks like a legitimate bank.com website, right? For the naked eye, you don't see a difference, right? But of course, if you go into the browser details and certificates and things like that, you can see, but a regular user may not go into that level of detail. So it's very hard to detect that, right? So he might be sending his username, passwords and everything, and the OTPs and everything, and that's going to go through this man-in-the-middle site, right? And the thing is, the user also doesn't know that this is going through the man-in-the-middle site, and even the server doesn't know, because it feels like it's a legitimate user who is sending the credentials, right? So both parties don't know. However, with FIDO or passkeys, what's happening is, as I said, the key that is established is specific to bank.com, right? So the moment the attacker does a man-in-the-middle attack and exposes exposes bank-secure.com to the user, although the user may not know it, the authenticator is not going to release the private key, because it has registered the private key with bank.com. So it will only try to find the key that is registered with banksecure.com. So therefore, even if the user is unaware, the authenticator is taking care of the phishing attack, right? So this is not available with traditional second factor methods such as SMS OTP or email OTP or whatever. And then I said the keys are specific to the device and the service. And later on, they introduce multi-device passkeys, which adds a little bit more convenience, but it's not as secure as the device-bound passkeys. So with multi-device passkeys, your key is going to be, so you have this ecosystem services, right, like Google and Microsoft and Amazon and everything. So for the convenience, what they do is they use a single key and synchronize it across multiple services in the cloud, right? So it gives you much more convenience, but of course the key is shared across multiple services, in that ecosystem, right? So it's still a good balance between convenience and security. So as I said, FIDO is widely adopted, and now NIST also has acknowledged FIDO as a upcoming standard, and they have recognized them in their authentication assurance level document. So for the device bound passkeys, it has a assurance level of 3 in the NIST specification, and for the multi-device passkeys, it has an assurance level of 2 in the NIST document. Okay, so then moving on with authentication. Typically, we have redirect experiences in our authentication. So I spoke about the OIDC protocol, right? Even if you take SAML, you take WS Federation, all these protocols, when you talk to an identity broker, is using a redirect-based approach, right? So what this redirect-based approach could cause is, it could cause poor user experience, where you have to leave the application, the browser or the mobile application or the desktop application or mobile application, and redirect. Now for browser web applications, it might not be that big of an issue, but for mobile applications, it causes poor user experience. And why they do that is because they want to make sure that you are entering the credentials in the identity broker and not giving it to anyone else. So this has been the traditional security principle, right? Not give your credentials to anyone else. But more and more what we are seeing is that the applications that we work with are first-party applications, which is the company who is owning the credential itself providing the application. For example, if it's Facebook, you have a username password in Facebook and you are using the Facebook application. So it's their own credential. So it doesn't matter even if it's the Facebook official application, you can give the credential to it. So more and more we are seeing applications like this, and this redirect experience is causing poor user experience. So we want a more native experience in the application. So the solution for that, the solution that is devised for that is, we haven't changed the standard. It's still OIDC authorization code flow, which is the most common adapted flow for single sign-on, login and single sign-on. It's the same flow, but the only difference is, it's instead of redirecting, we are calling APIs that are that are exposed from the identity broker or identity server. And so this is how the flow goes. So there is a special response mode which is called direct. So when you say direct, the identity server or the IDP will identify that this is a native flow that's going on. And what it's going to do is it's going to send back the content that needs to be rendered in the client device, right? So it's going to send the instructions for the content that needs to be rendered in the client device. So based on those instructions, the client device is actually going to render the forms, the input fields, and collect the credentials, right? So this will go in kind of a loop until all the steps that are configured in the IDP are completed. So if there is a multi-factor authentication process, first step username password, second step OTP, this is going to go in a loop for 2 times. First time it's going to say collect the username password, and once that is successful, it's going to again say collect OTP, and after that continue with the authorization flow. So it's very similar. So instead of the IDP showing the page, redirect, because when you redirect, the IDP is going to show the page. Here it's going to give the information to the client so that the client is going to show that information and collect the credentials. So that's the main difference. When you have a social login like Google, of course, you can't collect Google credentials, right? So then typically what's going to happen is Google has its own SDK, mobile SDK. So when the IDP says, now you need to get input from Google, the mobile application is going to use the Google SDK and do the login with Google. So again, it doesn't have to redirect to Google. It can use the Google SDK and natively log into Google. So that's how you would handle social login in those cases. And when there is a SSO requirement, because typically when you do browser redirect based logins, the SSO works based on the browser cookies, right? So when there is a browser cookie that is attached to the identity broker, the identity broker knows that this is the same user that is logging in. But with these mobile native applications, there is no cookie as such, right? So however, in this protocol, there is a session identifier which needs to be shared across applications through secure storage mechanism in the mobile application. So there is no standard for this, but you can use kind of a secure storage mechanism within the mobile application, mobile OS. And as long as the session identifier can be shared to the other application, the second application can send the session identifier in the login request, and then the IDP is going to accept that and send you back the code, right? Rather than going through the authentication steps again, right? So that's how it works for native applications. So then we'll touch upon this decentralized identity and verifiable credentials concept. So this is basically in traditional identity federation, the user's identity and attributes and information are going to be stored within an organization, right? So your identity is always bound to an organization, right? Which means that the organization is also taking some level of risk in collecting this information and storing within themselves. So this is kind of unnecessary. So this is where the experts got together and decided, what if we don't have to create identities for users within an organization, but rather give the control of the identity to the user himself or herself, right? So that's where the users can have their identities in wallets, right? So that is basically the idea how this decentralized identity came about. So in the decentralized identity architecture, there are some important components. You have issuers who are going to issue verifiable credentials. Then you have the holders, which are basically the users, and they will have a wallet, and the verifiable credential is going to be stored within the wallet. And then there is verifier, which is basically the service that the user is trying to access. So whenever you access a service, you will present your verifiable credential in the wallet to the verifier, and the verifier can verify this credential and give you access. So what is interesting about this architecture than a traditional identity federation architecture is that in a traditional identity federation architecture, whenever the verifier needs to verify the credential, it needs to contact the issuer and see, okay, is this credential valid and did you issue it to this user, right? But in this architecture, basically, the verifier doesn't need to contact the issuer. It can verify by connecting to this identity trust registry or identity trust framework. So this is why this architecture is called zero knowledge proofs, because even the issuer doesn't know that the holder is using this credential in order to get access to the verifier. So it's really privacy preserving. So issuer doesn't know about what the holder is doing, and verifier doesn't know kind of who the or anything about the issuer, right? So it all depends on this identity trust registry. So that's what really makes this very scalable and really privacy preserving. Okay, so then moving on with authentication. So we spoke about multi-factor authentication, but now today we are going beyond multi-factor authentication, and we have adaptive authentication, right? Adaptive authentication is basically considering more contextual information from in that login event, right? So you're looking at various signals. You're looking at situational signals, you're looking at behavioral signals of the user, you're looking at credential-based outcomes and shared signals. So there are various categories of signals that you are looking at in order to arrive at a decision, an adaptive authentication decision. And also the adaptive authentication is during when the user is actively logging into the application, but also we have this concept called continuous authentication. So continuous authentication is even after logging into the application, the system is continuously evaluating the trust level that was associated with the login event, right? So even if there is some suspicion or some risk event that is happening after login, it's going to go back and kick you out from the application. So that is what we call continuous authentication. So in order to facilitate this continuous authentication, we need a lot of signals, right, from various sources. And these shared signals is a standard that is coming up in the shared signals working group under OpenID Connect, which is called CAPE, Continuous Access Evaluation Profile. And they define these different kind of events for which applications and identity providers can react to, right? So this is a standard, right? So which means these identity providers and applications need to be able to receive and send events between themselves. Okay, then moving to authorization. So authorization is typically defined in an identity broker, right? So which is what we call the design time. And then authorization can be enforced either at admin time or at runtime. So typically when you say authorization being enforced at admin time, that is when you're creating a user, if you're going to give roles to that user based on his the department he's working or the function he performs, that is defined at admin time. So those are static, they don't change much, right? So that you can decide at admin time. But there are more dynamic authorization that you can get, which needs to be evaluated and enforced at the runtime, right? So for example, if you are provisioning a user to an application, that decision can be done by the admin in the IGA, right? IGA is Identity Governance and Administration. Typically, that's the system that you would use to provision. So that decision is made by the admin when the user is provisioned itself. So whenever the user is trying to access, that decision is already made. So it's a it's already pre-authorized when he's trying to access. So this is static authorization at admin time. So when it's more runtime authorization, when it's more dynamic, you need a policy-based authorization architecture, right? And typically this is the accepted architecture for any policy-based authorization engine. Now there are various technologies when it comes to policy-based authorization. There is OPA, there is SACML, there's various technologies, but then the architecture is this, right? So there are some components here. Very quickly I will explain. So there is PAP, which we call the policy administration point. That's where you design your policies or author your policies, and those policies are going to be stored in the policy store. And then there is a PDP, which is the policy decision engine, which is going to decide whether the user gets access to this service or not. And then there is a PEP, policy enforcement point, which is actually sitting in the service, right? If it's an API, it's an API gateway. If it's an application, it's some sort of a proxy or a filter or a valve in the application, which decides whether to allow the request to go through or not. How is it deciding? It's going to talk to the PDP, who is going to evaluate the policies and decide whether this user with this context can access this resource or not. And policy information point, PIP, is when you need some additional information. In addition to what is sent in the request, you need additional information about the user or the resource they are trying to access, or any other additional information in order to make that decision, right? So according to that policy, there is additional information that is needed. So then you talk to the PIP. So this is basically the fundamental architecture of policy-based authorization. So typically, how would you design policy-based authorization? So if there is a portal, right, traditionally what we would have done, we would have written the authorization logic within the portal or within the web applications, right, which is not correct, right, because that means your authorization logic is baked into the web application, so it's hard to kind of change them, hard to visualize them, hard to understand. But the ideal way of doing is that you have a policy enforcement point in front of your portal, which is going to check for the authorization of the user with the PDP, and if it's valid, successful, then it will allow the user to go through. So when we look at the modern authorization technologies, so there are many technologies in modern authorization, starting from XACML all the way to Zanzibar, OpenFGA, etc. But so there are two categories mainly. One is policy as code, that is ABAC. So some of these technologies fall under ABAC, and some of the technologies fall under relationship-based access control, which kind of builds a graph model in order to model relationships between entities and decide the access control. ABAC looks at attributes of the different entities and decides on the access control. ABAC is of course more powerful, but there are certain use cases for which REBAC is really useful. Either way, there are certain things that weren't standardized. So these are all ways you write policies, right? But there are certain things that weren't standardized for a long time. One is how the PEP is going to communicate with the PDP, right? For example, how the API gateway, which is protecting the API, how is it going to communicate to the, say, a XACML engine or a OPA engine and see whether the user can get access to the API. So the PEP, PDP communication was not standardized. So very recently in 2024, there was an effort that was started in order to standardize some of these things, right? So that's the ODZEN Charter, and they have started this journey of standardizing the communication points between PEP and PDP, PDP and PAP, and PDP and PIP. So the very first focus was on PEP, PDP communication, which is already now a draft, and there were multiple interop events that were happening last year and this year, so we also took part in those interop events, and now we are also listed as a vendor who is compliant both on the PEP side with the API manager and on the PDP side with the IAM on the ODZEN website. Okay, so we looked at authentication, we looked at authorization, then we come to access delegation, which is basically, it's a cool term to say calling APIs, right? How you call APIs. Why we call it access delegation? Because the user is giving access to the application in order to call the APIs with his permissions, right? That's why we call it access delegation. So I just wanted to allude to this zero trust architecture, because traditionally, if you would have thought, if I have logged into the application, I should be able to access any API. But that is not the case with zero trust architecture. Zero trust architecture forces you to continuously assess explicit risk or trust levels, and also consider the identity and the context, not just the identity but the context. So the context also can differ over time. So whenever you access the API, you need to consistently validate that the required authorization levels are there. So in an API gateway architecture, typically there is a client and then there is a resource, and you're going to access an API. And as we saw before in the authorization section, there's going to be a PEP who is going to validate with the PDP and check whether the client has authorization in order to access the resource. Now, when you say the client is accessing the resource, the client can either access the resource by itself or on behalf of a user. So the token will carry this, the access token will carry this information. It will say what are the permissions that are there for the client or for the user, and based on that, you can get access to the resource. So there are two ways the PEP can authorize actually. It can either validate the request that is going to the resource, and it can restrict what can be done in the resource, or it can filter the response, and it can maybe drop certain data from the response, or it can mask certain data from the response and give it back to the client. So both things can be done with this pattern. Then when it comes to kind of a inter-service communication in a service mesh architecture, the same pattern applies, but with slight difference, where typically you will have, of course you need a PEP in each pod, because when pods are calling other pods, you need a PEP, so to enforce that. But also you might have a PDP, a local PDP, as a sidecar, maybe, because in order to optimize the performance, because when it comes to service-to-service intercommunication, there can be lots of calls going, so there will be a lot of calls back and forth. Therefore, the performance is critical, right? So if there is like a centralized PDP, and if the pods have to always communicate with the centralized PDP, it's going to take a lot of time. So what's going to happen is typically you have a centralized PDP where you will do the administration, but then those policies are going to be pushed to the local PDP, and there is a local PDP that are running the policies locally with cached decisions, so that it's faster for the pods to communicate with each other, right? So that's typically the architecture. So then we have some additional authorization patterns when it comes to these API gateway architectures, right? So one of the cool things about OAuth 2, if you are familiar with the spec, you can check it out. So OAuth 2 doesn't say, it nicely decouples the authentication of the user from the access delegation part. So like I said before, OAuth 2 basically what it does is it gives permissions to the OAuth 2 client, like a token with permissions, in order to access the backend resources, right? But in order to do that, it authenticates the user first. So that's what we saw in the authorization code flow. When the user is redirected, he authenticates first. How does that authentication happen? That is not defined in the OAuth 2 specification, right? Or the OpenID Connect specification. That is decoupled. So that way, the user doesn't necessarily have to authenticate at the IAM. So if you look at this pattern, there is an API gateway, and the API gateway is trusting the IAM system for the token issuance, but the IAM is not authenticating the users locally. It is federating to other authentication providers, because the users are there, their accounts are there, so they authenticate from the federated identity provider and come back to the IAM, and IAM issuing tokens for the federated users, right? So that's a very common pattern we see, how the identity is federated in an API gateway scenario. Similarly, a similar pattern exists when if the application is already written in a way that it already connects to the federated identity provider and authenticates the user, then there is another protocol called token exchange, where you can exchange that identity token, say an ID token or a SAML token, you can exchange that to the IAM system. So this is an API call, you don't have to do any redirects or anything. Exchange that, get an access token, and then call the backend APIs. So that is a back channel federation. Then you might have you might want to externalize the authorization server completely to other parties. So you might only have a gateway, but you might want to connect to external authorization servers or key managers, as we call it within WSO2 sometimes. So we can integrate with multiple key managers that are external to your organization or external to your BU or team or whatever that boundary is. You can connect to multiple authorization servers. That means the authentication is also delegated and the token issuance is also delegated, right? Both are delegated in this case. And this is also a kind of a variation of that pattern where you have the gateway, and then you have multiple backends. Each backend has its own authentication provider, right? So the backend is specific to the user base that is accessing, right? So these are some patterns that we've seen with customers. So here, how we can do this is, when you federate the authentication to, say, authentication provider 1, and when you generate the token, within that token, you can, or rather, once the authentication is completed, the IAM in the middle is going to generate a token. Within that token, you can specify that this token was, this authentication happened with authentication provider 1, right? So then when the token is sent to the client and the client calls the API gateway, the API gateway can identify based on the token where the authentication happened, and then dynamically route to the correct backend, right? So this is also kind of a pattern that we can use. Okay, so we looked at different gateway patterns, but then the next step is now the gateway has to turn around and call backends, right? So now it's not sufficient to authenticate just to the gateway. You need to also propagate that identity information to your backend systems, right? Because there may be certain additional authorizations that need to be performed in the backend system. So we call this identity propagation, right? So there are mainly two popular ways of doing this identity propagation, right? One is to say one is called the trusted subsystem. So that is to say the gateway is a trusted system, it's a trusted subsystem. So the client is going to authenticate with the gateway that is using the OAuth access token, and whatever the gateway says, the backend is going to trust. So if the gateway says this is the client who authenticated, and it sends a header or something like the custom message, custom payload, and says this is the client who authenticated, or this is the user who's authenticated, it's going to be trusted by the backend, right? And the integration gateway may call the backend resource server, and there can be another trust relationship there. So that is basically the trusted subsystem. There is no way to verify. You are just trusting the subsystem that it has done the right thing. It has authenticated the user and passed the correct information. So this is, this is very commonly used, but not the most secure way of doing it, right? Slight variation to that, the token, instead of the gateway generating the token can be generated from the trusted IAM system. Still, the backend is, of course, trusting the IAM system, saying that it has correctly validated the user, right? Whatever the token that is sent, the backend is going to trust. Now, this will work. This will, usually work within an organization, because within the organization, most of these systems are going to be trusted within the organization boundaries. But when you go to across the organizations, when you call out into other organization, this may not work, right? Because the domain A is going to have its own authorization server, domain B is going to have its own authorization server. So that is not going to typically trust the resource server there, is not going to typically trust the IAM system here, right? So that's where we need to establish this trust relationship between the two IAM systems, right? And how that's going to work is, that's based on this protocol called token exchange, right? So the client, as usual, is going to get an access token from its IAM system, and then it's going to call the gateway. Now, when the gateway calls the resource server in the other domain, it can't just send a token that is generated by itself. It needs to exchange that token to a token from domain B by calling the domain B authorization server. And what domain B authorization server is going to do is, it's going to validate the token that the client sent, and it's going to give back a token that is issued for the gateway, but on behalf of the client. So the information is encoded in the token, saying this token is issued for the gateway on behalf of the client, and then the gateway is going to call the resource server. So now the resource server can very clearly identify who the actual user, who the actual end user who did the call is, and the gateway is the actual one who did the call, but on behalf of the client. So both information can be verified by the resource server. So this is a more scalable way and a more secure way of doing it, but it involves a little more work. Okay, then we look at some CIAM ecosystems. So most of the concepts that we discussed so far applies equally to customers as well as employees. But these are some specific things around consumer-facing IAM, right? With consumer-facing IAM, what we've seen is that there is a lot of integration requirements with consumer-facing IAM. So customer data resides in many systems. And also there are many technologies, ecosystem players that you need to integrate with. Like I said before, for identity proofing, there are ecosystem players who specialize on that. There are social logins for decentralized identity, for example. So we need to integrate with many of these specialized vendors. So in order to integrate, we need to be able to integrate using APIs and events, right? So we need to expose our capabilities as APIs, as well as we need to be able to call out into other APIs, as well as we need to be able to emit events when there are interesting, useful things happening to the identities in our system, so that the other systems can consume those events, right? So these are some fundamental capabilities that are expected. So integrations play a vital part, especially in the B2B side of things, which we'll talk about later. Integrations are very important when it comes to B2B. So this, for example, talks about how you can do a registration flow, right? So there are multiple ways of doing a registration flow. For example, say the most simplest way of doing a registration flow is basically say an account manager is sending a invitation to the customer admin, and then the admin is onboarding to the system, right? So that's the most simplest way of doing the registration flow. It's a sales-led onboarding, right? On the other hand, the same onboarding can happen by the customer coming to a self-registration portal, and the self-registration portal is going to kick off a process in the CRM system, which also ends up in the same state, right? So the entry point is different, but it goes through the same workflow. And then there can be other ways of a third-party client who is onboarding a partner, and that also kind of goes into the self-registration API and kicks off the same process. So there are multiple ways in which you can kind of get entry into the process, and the same process will follow, right? So that's basically why we need these APIs and events, right? And then, of course, runtime extensibility is important. So in the process, you may need to connect to external systems like HubSpot, ServiceNow, etc., as well as if you may want to write some extensions, right? So this is important. Every business has its unique requirements. So the out-of-the-box products is sometimes not able to satisfy all your requirements. So you need to be able to extend the product. So in order to extend, in the old world, when we have Java-based products, we can easily extend it with code. But when it's like a SaaS service or something like that, it's not as easy. So then we need to provide ways of extending SaaS products, which is why we have provided these API-based extension points, where we will publish an Open API contract, and then you can write your service based on the Open API contract, and then we will call that service whenever we execute the flow. So that's how we write extensions in our SaaS or hosted versions of the product. So this makes it very easy because you don't need to recompile or redeploy the product, and it makes it very easy to run these kind of extensions in serverless architectures or cloud-native architectures. And you can write these services in any language. You don't have to, even though our product is in Java, you can write it in any language. So those are advantages that we have. So then we talk about CIAM. So CIAM is a very connected architecture. So CIAM connects to various systems, as I said. So because customer data is residing in many systems, so that's why we need a lot of integration and aggregation. So we need visibility into customer data, and then we need to be able to build the intelligence and action that, right? So when I say action that, it can be making some decisions in the authentication flow, it can be making some decisions in the authorization flow, and more importantly, personalization. So you can personalize the experience based on the identity data that you have in different silos by integrating that identity data and providing a personalized experience to the customers. So on that front, actually, more recently we have started this effort. we are building a service which we call the customer data service that recognizes that there is value in the identity data that we collect, and we want to be able to use this identity data and provide a very personalized experience for the customers, right? So this may sound very similar to what a customer data platform would do, but customer data platform is mostly a marketing tool that has various other purposes, but we are building a very focused kind of customer data service that mainly focuses on how the verified identities are going to be linked to the user profiles that the user information that we collect and make useful decisions and impact the personalization. So that's the objective. As well as, customer data platforms are very expensive products. Not all organizations can afford customer data platforms. So this is going to be a very cost-effective solution for people who are starting out to try, to build that unified profile of their customers. So that's basically at a high level. At a high level, that's the idea. And also, we believe that CIAM is the right place to do this because you're collecting customer data. So security, privacy, and consent becomes very, very important. So we have those capabilities built in, right? So that's basically the idea. So basically, there are customers are accessing multiple applications. These applications generate data for customers. Then there are other traits of the customers that you collect through customer interactions. So all these data can be centralized in the CDS, Customer Data Service. And once a verified identity gets onboarded to the system, we can link the verified identity to the customer data that we've collected. So the CDS will start collecting data even when the user is anonymous, right? It doesn't have to be verified identity. It can be anonymous, but once there is a verified identity created, we can link that to the data that is already collected. Okay, so then we looked at the kind of consumer-facing or employee-facing side of things, and very quickly we'll look at the business-to-business interactions. So how we look at these business-to-business interactions in terms of the capabilities of B2B, what we believe is that all the capabilities that we saw for the B2C are also relevant to B2B, right? So basically, maybe there are like few things slightly different. So for example, maybe you won't use much of social login in B2B, right? But still the identity federation is the technology that is used, but maybe not with a social website, right? Maybe the account linking is used, but you might not use like implicit account linking, you might use explicit account linking. So there are like minor differences, but the technology, the core technology requirements are the same, right? But B2B has its own unique requirements. So basically, we look at B2B as a superset of capabilities of the B2C requirements, right? And what are the additional requirements in that superset, right? So I'm not going to spend time in this. So the same areas are covered, but there are some special use cases that are highlighted here, which is the additional stuff that comes with B2B. So with B2B, basically, so we have within our identity broker or within any identity broker like a SaaS identity broker, which we call IDaaS, you can create multiple organizations, right? We call them organizations or tenants, right? So each company will go and register as tenants or organizations. And each company will have its own users, own applications, policies, groups, etc., etc. So these are completely isolated tenants or organizations. And this sort of a platform is what we call an IDaaS, right? So an IDaaS means it's providing IAM capabilities for multiple organizations or multiple tenants, right? So for example, the WSO2 SaaS IDaaS Asgardio is a setup like this, right? So for that, the core IAM product that we have, Identity Server, has these multi-tenancy capabilities. So this is kind of one kind of organizations, right? Then if we zoom into this one of these organizations, right, one of these tenants, within that tenant, you can have sub-tenants or sub-organizations, right? So this is one use case. Within a tenant, you can have sub-organizations for B2B SaaS, which is one use case. So what is B2B SaaS? If you are having applications, SaaS applications, that are consumed by other organizations, external organizations. That is what we call B2B SaaS, right? So why is this different from B2C? In B2C, you're always authenticating, onboarding and authenticating and verifying a single individual user. It's either a consumer or an employee. But with B2B IAM, you're actually verifying a user as part of an organization, right? So the organization is important. So the organization's identity is important, right? So that's the specialty with B2B. So this is one use case, B2B SaaS, where your SaaS applications are being accessed by multiple customers. Another use case is, for these sub-organizations, is the teams, right? Internal teams or internal organizations. So when I say teams, it can be teams, product lines, BUs, any sub-unit or region or whatever. Basically, within a large organization, like a large corporate organization, maybe a global organization, there can be multiple teams or business units or whatever, which have their own applications, right? But there are also shared applications. So then you should be able to, govern shared application access for each of these teams, but the teams should be able to govern their own internal applications in the same platform, right? So this kind of a setup is what we call these internal organizations, right? So this is another use case for sub-organizations. Then the last one there is actually sub-brands. It's actually not B2B, it's B2C. But this is another kind of interesting requirement we see with many organizations, where there are multiple brands that are within the same organization, and there can be multiple teams. Sometimes there are multiple teams that are managing each of these brands, and most often there are different consumer bases for each of these organizations, right, sub-organizations. But they're all managed in the same IAM platform, right? That's the most important thing. Otherwise, this doesn't make sense at all. You can have just two different deployments or two different tenants or whatever. But here, it's basically part of a single platform. So there are a common set of platform administrators who still need to manage these individual brands, but then there are brand specific, say, developers or admins also in the same platform. So that's where you need this kind of overarching governance, as well as dedicated administrators for the brands, and then they have their own consumer bases as well. So these are like the different use cases that we can achieve with the sub-organization model that we have. So drilling a little more deeper into the B2B IAM side. So what are the special capabilities that we can see? So with the sub-organizations, one is that the sub-organizations are hierarchical. So it's not one level of sub-organizations, you can have multiple levels of sub-organizations, right? So sometimes there are requirements, you need to model a hierarchy of sub-organizations. Then each sub-organization has capabilities to manage users, manage their own groups, etc. Then the most important capability is the delegated administration. So as the platform provider, you don't want to manage individual users within the platform, right? So what you want to do is you want to delegate the administration capability, say of customer A. The customer A employees has to be managed by the customer A admin, right? So, but he can't manage customer B employees, right? So you want to compartmentalize that administration boundary, and then you want to give that rights to the customer A admin. Likewise, you can do delegated administration, and then within the sub-organization, that customer admin can maybe give another set of roles to his employees to do certain things, right? So that's basically delegated administration. And then each sub-organization, you can have different login options, right? So the default may be username password, but another customer can come and say, I want to plug in my own enterprise IDP, right? So then we provide options to plug in your enterprise IDP. The customer or partner can plug in the enterprise IDP instead of username password. Another customer may come and say, we already have passkeys. So we want to enforce passkeys for all of our employees. If our employees are accessing, they need to access with passkeys. So we can facilitate that. So what this means is that you don't have to change your applications in order to facilitate all of these. These are all configuration driven in the identity server. I think we are almost out of time, so I'll not go into some of these more details. Yeah, so that's it. That's the end of my session. So just as a summary, I just put out this slide, but I'll not go through this. Maybe you can take a look at it later. How the different areas of IAM have evolved over time from traditional to modern to future. So I think this gives a good summary of what's coming up, what was there and what's coming up. Yeah. So that's it for my session. If there are any questions, I can answer, or we'll be around so you can come and chat.